Yeah, hi guys. Thanks for joining the session and welcome to Tungbhadra Networks once again. And let me introduce myself. My name is Karthik and I am dealing Palo Alto codes here in the Tungbhadra Networks. Okay, so here in the first session, so we are mostly dealing with the Palo Alto, right? So we can learn extensively about how the Palo Alto firewall is important in the security and how well we are going to learn about the Palo Alto. Okay, so the first session will be about the firewall fundamentals. Okay, so in these firewall fundamentals we are going to learn about what is a firewall first. Okay, what is the importance of firewall in security domain, and especially when coming with Palo Alto firewall, what are the security features that are going to provide by the Palo Alto firewall, and what are the hardware types that we have. Okay, and how this Palo Alto firewall is going to provide security to your network. Also, what are the zones that we have in the Palo Alto, and we'll also having interface types. Okay, all this we are going to learn in the firewall fundamentals. So yeah, uh, here first thing, why we need firewalls in the network. Okay, so mostly, as you already know, I think, right? So you are well aware of routing and switching. Okay, so this routing and switching mainly will tells you how to send the data. Okay, where to send the data. Okay, but the firewall in your network will, okay, will deliver the data or will send your data in a secure manner. Okay, secure manner in sense that we'll discuss in the later in the sessions. But the firewall in your network will be provide security to your data, whatever the traffic that is coming and going. Okay, so in routing and switching you mostly learn about how data flows and where data flows. But when coming to the firewalls, how data will be secured, and whenever you are sending something to the internet or whenever something you are accepting. Okay, whenever you are accepting the traffic. Okay, uh, towards your private network, how these firewalls will work, that we are going to learn in this. Okay, so firewall is an security device. Okay, where it can filter, it can inspect, and it can control your incoming traffic as well as outgoing traffic. Okay, so incoming traffic, nothing but, okay, let's assume this is the internet. Okay, or we can call it as an public as well. Okay, this is your inside network or private network. Okay, so whatever the traffic coming from public to private, that will be calling as an incoming traffic. Okay, or inbound traffic, or whatever the traffic that is flowing from your private network to the public or your, okay, inside to the outside, that will be calling as an outbound or outgoing network. Okay, outgoing traffic. So what this firewall will do, what the firewall will do with incoming and outgoing traffic. Okay, so once the traffic receives on the firewall will verify. Okay, and inspect your traffic. Okay, let's suppose you are accessing or you are pinging 8.8. Okay, so you can say ping 8.8.8.8. Okay, so if oh, sorry, here this is your internet, right? So now I'm pinging from this PC. So you are initiating ping 8.8.8.8 from your PC IP. Let's assume 10.10.10.1. Okay, so what will be the source IP and what will be the destination IP here, guys? What is the source IP and what is the destination IP here? Yeah, yeah, 10.10.10.1 is the source IP and destination IP is 8.8.8.8. What will be the source port and what will be the destination port? When I'm pinging from a PC to 8.8.8, what will the source port and what will be the destination port? No, no, I'm pinging. I'm just pinging 8.8, 67, 68. These are the DSCP, right? I'm just pinging from 8.8. Source port will be random. Yes, that's correct. Uh, 53. No, I'm not querying anything. I'm just pinging from 8.8. So what protocol this ping will use? ICMP. Does ICMP have port? That is protocol number, not port. Does ICMP has port number? One is a protocol number, not port number. Okay. Protocol ICMP is a protocol which is a protocol number one, but ICMP does not have any port. Okay. So the destination port will be zero here. Okay. So with this packet, we are sending the traffic. Okay. We are sending the traffic towards 8.8. In between, we have a firewall. What firewall will do? Guys, can you please go on mute? I think someone, Mahesh, Mahesh. Yeah, thank you. Sorry. So whenever we are pinging from your, okay, uh, your PC to 8.8 with source IP, your PC IP, destination IP will be 8.8, source port will be random and destination port will be 0 here in this case. Okay. So when this traffic receives on the firewall will verify whether this traffic has to be allowed or has to be sent out or not. How can it verify means? So using rules. Okay, here we are going to create rules. Here in the Palo Alto we will be calling as an security policies. Okay, and I think in the routing you have learned about ACLs, right? So in the ACLs you are defining what subnet needs to be permit, or what is the port number, what is the destination port that you want to allow. So here in the Palo Alto we are calling as an security policy. Okay, so using a security policy we are defining in the firewall what type of traffic has to be sent out. In the same way, whenever you are receiving the traffic from outside, what type of traffic and what subnet that we need to allow towards our private network. Okay, using this security policy, the firewall will going to control or monitor the incoming and outgoing traffic. Okay, so this is how the firewall is going to uh, provide security to your network. Okay, not only using, okay, IPs, not only using ports, these firewalls will also provide, okay, security based upon applications as well. Okay, yeah, so applications, user database. Okay, okay, so the firewalls will going to provide security based upon your IPs, ports, applications, and user database. Okay, those firewalls will be calling as a next generation firewall. Okay, those firewall will be calling as a next generation firewall. So we can discuss about, okay, what is next generation firewall. Before that, you want to know about, yes, just a minute. Yeah, I'm back, guys. So we have learned about firewall, right? So what is a firewall, how firewall is going to provide security, how the firewall is going to monitor, inspect. But we need to know about, okay, something about traditional firewalls and next generation firewalls, how the traditional firewalls are going to work, and how the next generation firewalls are going to work. Okay, so let me tell you that. So first one is a traditional firewall. Okay, so do anyone know about traditional firewalls? Yes, guys, anyone know about traditional firewalls? Yeah, okay, no problem. So see here, traditional firewalls are those which provides, okay, which provides security based on L3 and L4 information. Okay, what is L3 and what is L4 means our layer 3 and layer 4 information based upon IP and based upon ports. Okay, so these traditional firewalls will be restricting, okay, to L3 and L4 only. So L3 and L4 means whenever you send this traffic, okay, so IPs, ports, whenever the firewall receives the traffic with IPs and ports, it is going to provide security. But whenever the traffic received with any type of application in the sense, let's assume you are accessing Facebook from your web browser. Okay, so web browser, what in the web browser, what is the protocol that the your PC is using? Whenever you type www.facebook.com, what is the protocol? HTTPS, right? Where HTTPS will work? Where HTTPS will work? Yes, application layer, which is our L7, right? Whenever this traffic receives on the traditional firewalls will not understand this type of traffic. Okay, this traditional firewalls will understand only till layer 4, L3 and L4. Whenever this type of application traffic reaches on the traditional firewalls will not understand this. Okay, to rule out this scenario, they have came up with solution of next generation firewalls. Okay, next generation firewalls are those which provide security till layer 7. Okay, it will provide security based on IPs, it will provide security based upon ports, it will provide security based upon applications as well. Okay, whenever you are typing www.facebook.com or www.instagram.com or amazon.com, anything that you are browsing on your internet or on your browsers, these next generation firewalls are capable of understanding layer 7 traffic. Okay, so traditional firewalls we can rule out from this. Okay, traditional firewalls will be ruled out from this layer 7 traffic as we have introduced next generation firewalls. Okay, not only this, these next generation firewalls will also provide advanced security features. Okay, what are the advanced security features means? The first one is deep packet inspection. Okay, whenever something comes in your network or whenever the firewall receives the traffic, it will not only, okay, verify sorry guys. It not only verify whether the traffic has allowed or not, it is also going to do deep packet inspection to identify if the traffic has any malwares, okay, or any threats or any antivirus, right? And it is also going to do file blocking, okay, and wildfire analysis. So all these things it is going to do. Okay, this will do a deep packet inspection means it will open the packet, it will verify whether the traffic is has to be allowed or not using security policies. Not only this, it will verify whether the traffic or whether that application has any malwares, threats, antivirus, or if that if you have sent any, okay, let's assume you have a receive mail with some files. Okay, so unauthorized files you have received. So what you can do, so instead of verifying the IP, instead of verifying whether this is an correct email or not, you are unintentionally will click the files that you have received through the mail. Okay, maybe that files will contain some, okay, malwares or antivirus will be there in that files. If you open, your system will be corrupted, maybe your system will be hacked by some hackers. Okay, guys, can you please go on mute? So I'm hearing some noise. Karthik Yadav. Yeah, so see here, whenever you hit that files or whenever you click on the files, maybe some unauthorized, okay, links or some antivirus are introduced, okay, into your system, and your system may be corrupted, and maybe your system will get, okay, will be getting hacked by some others. Okay, so in that case also we can use the firewalls to block the files. Okay, whenever you receive such type of files, okay, whenever you receive files in the form of .txt or .ppt or anything, okay, any type of files that you have received, whenever you are before clicking it starts downloading, right? So instead of that, the firewall will verify first, okay, the traffic, okay, the whenever you click on the files, okay, the traffic receives on the firewall, the firewall will verify whether this file has anything, okay, unauthorized or anything antivirus like that, the firewall will verify. And if something is identified by the firewall will block that file, okay, instead of getting access, the firewall will block the file, okay, so that we can safeguard our systems, okay. We can safeguard not only systems, then maybe that file will be getting, okay, multiple users in your network, okay. So in that case, so you can safeguard your entire network, okay. And also wildfire analysis, okay. So we have discussed about file blocking, right? This file blocking, how this firewall is going to verify all these things means using an wildfire analysis, okay. So if you have a wildfire analysis, so these type of files will be, okay, these files, this type of files will be inspected by the firewall. And if something is suspicious identified by the firewall is going to block. Or if you get a emails, okay, you are, okay, in corporate network you are getting many mails, okay, some mails will be, okay, getting from unauthorized peoples, so who are sending some links, okay. So you can get a mail from your, okay, the the mail looks like your company mail but not exactly your company mail, and they are sending like, okay, you for your dedicated hard work and continuous support, you have won an Amazon voucher of 4,500 5,000 like that, you will get a mail with the subject with your email same like as your company mail, okay. So what you will think, so this is my company mail, right? So you can click the link, okay, but this link is not exactly what, okay, this link is not the right one that you need to click, okay. In that case also, whenever you click on this link, the traffic will reaches the firewall, and the firewall will analyze the link, okay, whether any antivirus or anything that suspicious is available in this link or not, okay. So if something is identified, the firewall will block that here itself, it will not send an access to the your systems, okay. That's how the next generation firewalls are going to provide you provide security to your network, not only based upon the, okay, till layer 7, but also it will also provide advanced security features like this, okay. And next generation firewalls are also will work based, okay, will work as an IDS and IPS, okay. What is IDS and IPS means? IDS means intrusion detection system, okay. So here we'll be having intrusion detection system, okay. So what this intrusion detection system means? This intrusion detection system, okay, if you firewall is configured as an IDS, this will the firewall will, okay, just identify the threats, okay, it will identify the threats, plus it will alert the administrator, okay, it will alert the user that something is identified in your network, okay. So maybe if you have if your network if in your network, if some threats are, okay, injected, or if any antivirus is injected in your network, this firewall is going to identify, and it will alert the user or it will alert the administrator, okay. That will be an IDS, okay. So the next one is an IPS, which is an intrusion prevention system, okay. The intrusion prevention system, which will be going to identify the threats, plus it is going to block as well, okay. So instead of, okay, alerting the administrator, so it is going to block directly. So whenever some threats or antivirus or malwares are identified in a network, it will identify first, and immediately it is going to block that. Okay, instead of alerting, it is directly going to block, so that we can, okay, we can prevent the attacks on our network as well. Okay, these are the main functionalities of next generation firewall. Okay, now, so what is the, okay, if Palo Alto is an traditional firewall, is a next generation firewall. Okay, this will be an one of the interview questions that may ask. So now you may raise an question like, so you we have discussed about traditional firewall, we have discussed about next generation firewall. Okay, so what if, okay, is Palo Alto is an traditional firewall or next generation firewall? Okay, so that will be an, okay, one of the interview questions you may encounter whenever you are going on any Palo Alto, okay, interviews. Okay, so Palo Alto is an next generation firewall. Okay, so where all these features are going to support on the Palo Alto firewall. Okay, so apart from Palo Alto firewall, there is one more firewall which is an FortiGate. Okay, FortiGate firewall, which is a next generation firewall, which we have in our, okay, in which we have in our network security. Okay, the Palo Alto is one and FortiGate is also one. Okay, but Palo Alto has and some, okay, these are all the advanced features the Palo Alto is going to support. Maybe the FortiGate will also support, but not this many. Okay, the Palo Alto will have an extensive, okay, advanced security features which are going to provide security to your network. Okay, and now, so what are the features? Okay, we have discussed about the features that needed to provide security, and here we have some of the essential features that are required in day-to-day life if you want, if you are using Palo Alto firewall. Okay, so the first one is an traffic control. As we already discussed this traffic control, the firewall will monitor and filter all incoming and outgoing traffic used based upon the security rules that we have defined. Okay, so already we have discussed here, right? So whenever the incoming traffic receives or outgoing traffic receives, so the firewall will inspect the traffic using the rules that we are defined here. Okay, we are going to create a rules, and we are going to define what type of traffic needs to be allowed by the firewall, either it is inside or outside. Okay, so that we are going to define, so that we can avoid unauthorized access. Okay, so let's assume someone, okay, someone pretending like the user, but he is using some different IP. Okay, he is using some different IP from the internet and in trying to enter your network. Okay, but we haven't created any security policy to allow this. Okay, once this traffic receives on the firewall, it will verify the security policy. Okay, this security policy, it will verify if nothing is matching with the security policy, this access will be denied here. Okay, it will not enter outside. Okay, so that the traffic can control the traffic by using an security policies. Okay, that is the first thing. And second thing, protection against attacks, that is the second thing. So these are all we discuss about these attacks, right? So the deep packet inspection or advanced security features like against like malwares or threats or antivirus. Okay, all these things will be identified by the firewall, and it is also going to block if anything is identified as a suspicious. Okay, if nothing is identified, the firewall may allow based upon security policy. If something is mischievous or suspicious, something is identified in your traffic, the firewall will, okay, will immediately block that. Okay, that will be the second one. Okay, and the third one is on segmentation. Okay, this segmentation will work in the firewall. Okay, in a way how you are using VLANs, right? Okay, how you are using VLANs in the switching. So what VLANs will do in the switches, guys? What VLAN will do in the switching? It will create different broadcast domains, right? So in the same way, in firewall, segmentation will do. Okay, segmentation will do the same thing, because in this segmentation we are going to create zones. Okay, I will I will tell, we'll be having a separate topic on these zones, so we'll discuss later in this session. Okay, so here let's assume, This is the firewall. Okay, so in same like in the switch, if you are not creating any zones, okay, if you are not sorry, if you are not creating any VLANs, so something is you are sending traffic from one, okay, if you are sending traffic from one port, so it will broadcast to all ports, right? So in the same way in the firewall also, so if you are not creating a zones, anyone who is going to connect to the firewall will access anything. Okay, so this is my dedicated server which I have hosted some, okay, advanced tools, and which I have some okay personal information in this dedicated server. But someone in the internet setting, and he is okay connecting to my firewall, and is directly accessing my resources without any station, or without any blocking, he is going to access. But that should not be happen, right? Someone in the internet should not access my credential, okay, should not access my personal data, should not access my server which I have kept dedicated for myself. Okay, so in that situation, so what we are going to do is we are going to create a zones. Okay, so whoever connected to the internet, or whoever connected, who are who are the users that are connected inside of my network, I am going to create one zone. Okay, all the users will be available in that zone. Okay, all the users will be available in that particular zone. Okay, let's consider my inside zone I have named as an, let's assume I have created a zone and I have named is an inside zone. Okay, who are all the users, or who are, what are the interfaces that are uh, created or that are assigned in the inside zone? Those will only have access to communicate with them in the VLAN. Who are the, what are the who are the users that are available in the same VLAN, they will going to communicate, right? And the user in one VLAN will not communicate with the other VLAN, right? In the same way, when we are creating a zones, one user in one zone will not be able to communicate with the user in other zone. Okay, so now by creating a zones, we are restricting the access to the users. Okay, accessing the any personal or, okay, confidential servers or confidential information to access them. Okay, so in the same way in the VLANs also, the user in one VLAN cannot communicate with other VLAN, right? So this is the same way we can okay compare with the VLANs. Okay, zones are the things, zones are the thing that we are going to separate. Okay, separate the users or separate the networks based upon their, okay, location, or based upon their what we call network. Okay, so one network, if you feel that I need to secure, you can create a zone and uh, add all those things in the same, okay, in the one zone, and create one more zone, and send all the users to that particular zone. Okay, so that they only can communicate with each other. Okay, the user in one zone will not communicate with the other zone. Okay, that will be done by the segmentation. Okay, and sorry, the fourth one is an policy enforcement. Okay, so before we have discussed about the security policies, right? So whenever some traffic comes, the firewall will check the policies, right? So what is policy enforcement, right? So in the policies, we will be having an action. Okay, so we will be having an action. Inside the action, we will be having an multiple actions. Okay, one is an allow, one is an block. Okay, so block, instance block we can use deny a drop. Okay, so let me show you in the firewall, so that so this is a firewall. Okay, this is how the firewall look like. So whatever the traffic that comes, that will check the, okay, we will be having policies, security policy. So like this we are creating an okay security policy. So inside the security policy we will be all having an actions. Okay, sorry, I haven't shared entire screen, so let me share my screen once again. So you can see my screen right now. Yeah, so see here, let me show you from first. Okay, this is a firewall. Okay, this is a firewall, how the Palo Alto firewall looks like. Okay, so here in the in the dashboard, or in once you log in, so the login page will be like this, and we'll be having a policy tab. Okay, inside the policy we'll be having multiple things. Okay, this we can discuss later in this course. So we are discussing about security policies, right? So these are the security policies, and I have created security policies to allow the network, or to allow the traffic. So let's take this policy. So where I am allowing the traffic from, okay, my inside zone to outside zone, and here the action is allowed. Okay, we'll be having inside the action we'll be having multiple things: deny, allow, drop, reset client, reset server, reset both. Okay, so based upon your traffic we are assigning the action, right? So based upon the action we have defined, the policy will enforce this action on this traffic. Okay, so the user is coming from, okay, let's assume you have a user inside the network with this subnet, or with this IP address, but in this particular source. Okay, and he is going to the outside of the network. Okay, so outside of the network means, so he is going from your inside to outside. Okay, so inside to outside, but the firewall is in between. The firewall has to be enforce the action, whether it has to be allowed or not. What are the action we have set here? The firewall will enforce that, and if it is allowed, the traffic will be allowed. If it is blocked, okay, we'll be having two, okay, two things in to block the network, to block the traffic: deny and drop. You can use anything. I will tell this difference between deny and drop in the next session. Okay, so see here we can block using deny and drop. So whenever the action is set to deny and drop, the firewall will block your traffic. Okay, so likewise we can the firewall will enforce the action. Okay, the firewall will enforce the action based upon the traffic that we are receiving. Okay, so not only, okay, enforcing action based upon the IPs and ports, this will also enforce the action based upon application, users, and data flow, that now the data is coming inside or outside the network. Okay, and after enforcing the policies, so what firewall is doing is, firewall will monitor and logging the sessions. Okay, so whatever the traffic that is coming into your firewall, first the firewall will enforce the action. Okay, either it is allow or block. Okay, so if you want to know whether the firewall has allowed or the firewall has blocked your traffic, so we need to verify in the firewall. Okay, so I think in the router and switches you don't have this option, right? So if you are blocking some traffic, if your router is blocking some traffic, or if your router is dropping some traffic, you cannot see directly inside the firewall, right? Do you have an option in the routers, guys? Do you have an option in the router to see the logs? Yes or no? We can see the logs, live log, debug logs, but you cannot see the historical log right now. So you have faced an issue 3 days before. Now you cannot see that, right, in the router. Sorry, gray logs. Okay. Sorry. No, directly from the router I'm asking. Yeah, so you can see the gray logs, by maybe that is maybe some applications or syslog server that you are sending the traffic, or some sending the log, but directly from the router you cannot see. But in the firewall, what firewall is doing, whether it is blocking or it is allowing, what is the source IP, what is the destination IP, what is the source port, what is the destination port, all the things that firewall is going to, okay, log that. Okay, it will display the logs. Okay, so how it will means, so here if you see in the firewall we will be having a monitor tab, where it can, okay, whatever the traffic comes, that it will log like this. Okay, when the traffic has received, where the traffic received, from which zone to which zone it is going, what is the source IP. Okay, this is our exact the user IP, where it is going, what is a port 443 means he is accessing something, okay, from the browser using HTTPS. What is application? Okay, what, whether it is allowed or blocked. Okay, it will show the action here. What is the rule it is hitting? Okay, the session and reason, number of bytes it is received, all this information will log by the firewall. Okay, So monitor and logging will be helpful to have a visibility about your network traffic, and also we can identify what type of traffic that we are receiving, whether the firewall is blocking or allowing that type of, okay, that traffic from your network or not, that we can have visibility. Okay, so that is about the monitoring and logging. So we will be having the VPN support as well, okay, in the firewall. So in most of the firewalls you will be having a VPN support. Okay, so VPN support like IPsec, okay, and remote access VPNs, okay, remote access VPNs, and also SSL VPNs, all will be going to supported by the Palo Alto firewall. Okay, so these are the, sorry, DMVPN. Yeah, sorry guys, I have bad. Okay, so it will also support DVM VPN, or okay, GRE tunnel. It will also support. Okay, all these VPNs are going to support by the Palo Alto firewall. Okay, so these are the features that are essential in the firewall for the day-to-day activities, and we are going to use all these things in our lab, and we are going to configure all these things in the every lab. Okay, so these are about the firewall fundamentals, essential features. Okay, till now do you have any questions before moving further? Any question? Yeah, go ahead. uh, అవునవును అవునవును యా, ఇక్కడ మనం సెగ్మెంటేషన్ ఎలా వర్క్ అవుతుంది అంటే, జోన్స్ క్రియేట్ చేయాలని చెప్పాం కదా, మనం ఏం చేస్తామంటే ఇక్కడ మనకి జోన్స్ ఉంటాయి. ఇక్కడ ఒక్కొక్క మనం మనకి యా. ఇక్కడ మీకు హైదరాబాద్ అనుకుందాం, ఇది మీకు ఓకే బెంగళూరు అనుకుందాం. వాట్ ఎవర్ ద ట్రాఫిక్ దట్ ఈస్ ఇన్సైడ్ ద హైదరాబాద్, దట్ విల్ బి కాలింగ్ యాజ్ అన్ ఇన్సైడ్ జోన్ అనుకుందాం. ఓకే, so the traffic which is going out, either it may be Hyderabad, either it may be Bangalore, or maybe out of your company. Maybe there is one more branch in the Hyderabad itself. Okay, let's consider it. That will be an outside traffic. Okay, that will be calling as an outside network or outside zone. So we are directing the firewalls whether we need to send the traffic out to this, okay, outside zone, or outside the network, which are okay, which are not coming into your office, which is available, okay, which is available in the Hyderabad. Okay, so we are defining the zones to allow or block to such type of traffics. Okay, by creating a zones, either it is in the same location or different location, whatever it may be. Got it? Yeah, this will, we cannot, okay, we are not supposed to do anything. Once you, okay, once you deploy the firewalls, just we need to have apply one license that I will provide. Okay, once you apply that license, so the firewall will automatically going to okay, log all this traffic on the monitor tab traffic. Okay, we don't want to do anything, we can just have the basic license on the fire to work this monitoring and logging. Okay, yeah. Yes guys, any other questions regarding this? Yeah, I will take it as no, and I'll going forward. Okay, so see here in the Palo Alto firewall, so you may be, okay, you may question either the firewall, Palo Alto firewall is a hardware or a software. Okay, for that, the firewall, the Palo Alto firewall is both hardware and also the software as well. Okay, software will be calling as in virtual firewalls or VM firewalls. The hardware firewalls will be like how your routers and switches are there, okay, in your network. So the Palo Alto hardware firewalls will always start with PA. Okay, we'll be calling as an PA series. Okay, so and after that you will be having a model number. Okay, we will be having PA 220, PA 400, PA 800, PA 3200, PA 5200, PA 7000, and the newly introduced PA 1400 as well. Okay, we'll be also having PA 1400 that I haven't mentioned here, but this is a newly introduced. Okay, so you may get a doubt. Okay, so we are just going for a security, right? So why all these firewalls, why all these models? Okay, you may get doubt. Okay, so see here, based upon the enterprise size and based upon the traffic that is flowing in your network, we can go with the firewalls. Okay, so for small networks and small company size, you will be having a okay firewalls which the firewall which are capable of handling your network traffic. So for small companies or small branch offices, you can go with PA 220 and PA 400 series firewalls. Okay, so this PA 220 firewalls is available in our in our labs as well. Okay, PA 220 firewall we have purchased. Okay, we have purchased and is available in all our Hyderabad, Bangalore, Vizag, and Kurnool branches as well. Okay, we'll be having dedicated two firewalls to practice, or anyone who is willing to go to office and practice, you can use this PA 220 for lab purpose as well. Okay, so we will be having this PA 20. This is just like okay, just a small sweet box like okay. So this is a PA 220 firewall, just like a small sweet box which can handle with your hands as well. Okay, this will be going to this is going to support for this and PA 400. Okay, these are the PA 400. We'll be having multiple models in the PA 400 as well. Okay, so these are going to support for the small small branch offices or small offices. Okay, and if your branch grows, okay, let's assume you have a company with 50 users. So in that case you will be your network will be having less traffic, right? So at that time you have purchased PA 220 or PA 400 file. Now your company grown. Okay, some okay, you have recruited 100 or okay 200 employees. Now your these firewalls are not handling your traffic. Okay, maybe how these firewalls are differentiated means based upon the hardware. Okay, hardware in sense, so maybe the processor, okay, or the storage space, okay, or the sessions that are going to handle. Okay, based upon all these things the firewalls are going to handle. Okay, so if you are having a only 50 users, the processor will be having okay uh, less overhead on the processor, and that may work very smooth. Okay, if your employees are increased okay from 50 to 200, the overhead on the processor will increase and it may work very slow, or it may act very slow okay to your networking decisions. Okay, so in that case these cannot be worked. Okay, so now you have to upgrade some 220 to 400 series. Okay, now you have to upgrade to 800 series firewalls. Okay, these 800 series firewalls will work for medium size enterprise. Okay, medium size enterprises, so that it will handle the traffic, will be having higher processors and higher storage space, and will handle more sessions. Okay, whatever the traffic that increases, it will handle the more sessions. Okay, now from 200, okay, your company has grown very big. Okay, now your company became an enterprise level with 1000 to okay 2000 users, where okay your company became an medium to large scale. Okay, so in that case these 800 series firewalls will work, but the so okay like how we have discussed, okay, the traffic coming on your firewall will increase. Okay, and the f- the processor, okay, whatever the processor that you are using on the firewall, okay, the traffic will hit on the processors, and that may overhead okay on the processors and storage, and the sessions as well. Okay, so in that case these firewalls will react very slow, and that may be some delays in your okay response. In that case will we go with 5200 or 3200. Okay, these firewalls 5200, 3200 mostly used in the large scale enterprises where, okay, like Infosys, okay, Genpact or Accenture, all these will think, okay, all these companies will be there, right? Okay, MNCs. Mostly you can see these type of firewalls in the large scale or large enterprises, okay. And now, okay, your company has, okay, again grown big, and you are maintaining an, okay, data center now. Okay, you are providing network, okay, support for multiple use, okay, multiple customers now. Okay, your company has grown big and you are maintaining one data center, okay, in your in your network. Okay, so in that case, now these firewalls, okay, these firewalls will not be, okay, very much suitable when you have, okay, taken multiple customers and you are providing a support. At that time we are going with 7000 series firewalls, where these firewalls will be much reliable, okay, much reliable, and provide uh, much, okay, faster responses for all the customers at a time. Okay, so you can see these 7000 firewalls in ISPs or data centers. Okay, so that's how these firewalls are defined or designed in such a way based upon the enterprise supports, okay, enterprise levels. So these are the hardware firewalls that we have, and we'll also having in software firewalls. Okay, there are some customers who don't want to handle the physical firewalls. Okay, so they don't want to, okay, have the firewalls in the data centers. Okay, instead of that uh, they are going to import, or they are going to uh, place the firewalls in the clouds. Okay, or any VMs will be having VMware or ESXi or KVMs, right? VMs. So they will be maintaining the firewall from there, or they will be maintaining the firewall from the cloud database as well. Clouds like will be having Azure, AWS, or Google, Oracle clouds will be there. Right? We can also deploy these for software firewalls or virtual firewalls in the clouds or VMs, and we can manage. Okay, so these are also designed for if your company is small, and if your traffic is low, okay, network traffic, you can go with VM50, or otherwise based upon your company size on enterprise level, okay, network or network traffic, you can go with VM100, VM300, or VM500. Okay, we will be having these okay, VM firewalls that are going to support. Okay, so these are the hardware and software models, and these are some, okay, pictures that I have taken to show how the firewalls look like. Okay? This is also same like routers and switches as well. Okay, so all the networking device will design in same way to have access. Okay, and after the hardware types, we'll be having interface types in the firewalls. Okay, so if you see here, we'll be having multiple ports in one in one firewall, right? So in some firewalls you will be having RJ45. If you see, in some firewall we will be having fiber ports. Okay, this RJ45 will be, okay, only support up to 1 gig. Okay, 1 gig speed. But if you want to increase the network speed, so you can, okay, you can maybe, you have to bundle your ports like how you are doing ether channel, that you have to do that. Or you can use an SFP ports firewalls. Okay, the firewall which has SFP ports as well. Okay, these SFP ports will support up to 10 gig. Okay, and in some firewalls we'll also having some, okay, these firewalls will be having an interfaces which supports up to 40 gig or 100 gig as well. Okay, so based upon your requirement, here we'll be having, these are the ports that supports 40 gig or 100 gig. Okay, based upon your traffic as well, you have to choose the firewall. Okay, and now what are the interface types that are available, and how we have to use these interfaces using that interface types. Okay, so I think everyone has know about management interface, right? So what is the purpose of management interface in any networking device? You have also seen in the router there is one management interface, right? So what is the purpose of the management interface? Anything in the sense? configure. Okay, configure. Okay. Assigning IP on the management interface. But what is the main purpose of the management interface? Yeah, to access the device from remote location. Okay. So in every networking device, there will be one management port and one console port as well. If you see this firewall, you will be having management port here and you will be having console port. Okay. What is the purpose of console port? Yeah, okay. When device is down, that's correct. Any other answers? Yeah, for initial configure, whenever you buy a new device, okay, whenever you buy a new device, you need to configure something, right? So we don't have, yeah, we, yeah, that's correct. We don't have a management access at that time. So at the time, what you can do, you can take your laptop, okay. In laptop, you can configure, okay. You can connect the one RJ45 cable to your laptop. So using a serial port, you can access this, okay, this firewall, or yeah, using a console cable, you can connect to the firewall console port. Then you can access the firewall directly here using an the port that it is showing under the serial connection. Okay. And for the initial, or whenever the firewall is down, you can use a console port, okay, or console interface. This management interface is mainly used for accessing the firewall from the remote locations to, okay, from using a management interface, we can do anything, okay, configurations, or if you want to delete, or if you want to add, or if you want to monitor anything, you can do anything from the management interface. Okay. So in Palo Alto, we are mostly going to use management interface for, you can use HTTPS or SSH. Okay. So mostly we are going to use the HTTPS of the firewall. That means from the browser we'll be calling as an GUI, which is graphical user interface. We are using less of CLI. Okay. So I think in the Cisco you are mostly using commands, right? So to configure anything, we need to use commands. But in the Palo Alto, we are not. Sorry. In the Palo Alto, we are not going to use any commands. Okay. For configuration, we are not going to use any command. We are using graphical user interface. I have seen this, right? I have shown this, right? So this is a graphical user interface where we are going to, okay, log in using a management interface with the help of HTTPS. This will be calling as an web GUI. Okay. So this web GUI will helps you all the things that is required. Okay. You can just navigate whatever the things that you want, you have to configure, you can navigate, click on that, add, you can add anything. Okay. You no need to do any, you no need to remember any commands here. Okay. That is the main purpose of the management interface. Okay. And next we will be having an HA interface. So these HA interfaces are mostly used in the high availability. Okay. So I think some of you know about high availability, or some of you know don't know about high availability, but mm, most of you know VRRP, right? You guys know about VRRP. Why VRRP will be used? So for redundancy gateway, we are using VRRP, right? So in the same way, in Palo Alto, we are using high availability for redundancy gateway. Okay. So here in this case, we are going to use two firewalls. Okay, for high availability. So if you want to use two firewalls in the high availability, we need to use HA interfaces. We will be having two dedicated HA interface. But some of the firewalls will be having dedicated HA interface. Some of the firewalls will not have dedicated HA interface. Okay, I will show you. So, so if you see here in the interfaces, you will be having management console, and these are the our actual interface. Okay, I forgot to tell you, in the Palo Alto firewall we'll be having two planes. Okay, two planes in sense, one is an management plane and other one is an data plane. Okay, in the management we can also call it as a control plane as well. Okay, and other one is a data plane. Okay, so this management plane will, okay, control the management traffic of the firewall, and this data plane will control the okay our actual traffic, okay, routing part. Okay, everything will be under the data plane. Okay, this management interface will be there, right? This management interface will handle the management plane traffic, and these are the data plane interfaces where you are going to connect to the servers. Okay, you are going to connect to the switches, or you are going to connect routers, or you are directly going to connect the end devices. Okay, so where your actual traffic will be handled. Okay, these are the data plane interfaces. This is a management interface which is going to handle the management plane. Okay, apart from that, if you see on this 820, you will be having another set of interface. Okay, these are the HA interface. We'll be having two interface, HA1 and HA2. Okay, so it's a minute. Yeah, so we will be having two interfaces, HA1 and HA2. So in order to connect two firewalls in a HA, we need to have two. Okay, uh, in order to have in order to connect two firewalls in HA, we need to have this HA interface. Okay, the H1 is connected to here. We will be also having H1, right? H1 is connected to H1, and HA2 is connected to HA2. Okay, likewise, we need to have to form an high availability in Palo Alto, we need to have these two interfaces. We can learn more detailed about these two interfaces and high availability in high availability class. Okay, we will be having dedicated session for high availability. Okay, and third one is an tap interface. Okay, this tap interface will be mostly used for okay monitoring your network traffic. Okay, how it will means, so I will have an okay one good diagram here. Okay, so this tap interface will mostly use it for monitoring your network traffic. Okay, using an Palo Alto firewall, network traffic using an Palo Alto firewall. So how it will be means, let's assume you don't have this. Okay, you don't have this part right now. Okay, you don't have this part, you'll be having only okay your end device, switch, router and internet. Okay, so you don't have anything, uh, the Palo Alto firewall now. Okay, your traffic going to the internet and the response is coming. Okay, if you are accessing Facebook, your request going to the Facebook server, the Facebook server will verify your okay details, and it is going to, if the details is available, it is going to send a response and you will get an okay Facebook. So something okay, you are accessing something anything on the internet, but instead of responding your actual server, maybe some attacker sitting in the internet, instead of the access instead of the actual server, he is going to respond to you, but you don't know. Okay, you don't know whether this is an actual server or not. Okay, and your administrator, okay, let's come, your administrator came and he is feel like he want to know okay some what happening in his network. Okay, if you want to know what's happening in his network, so he want to monitor. Okay, maybe he want to add some monitoring tools, or he want to add some okay syslog servers to monitor. Okay, but if he feel that if he want to add Palo Alto firewall for monitoring his network, he want to use okay tap interface without changing any network configuration. Okay, without changing any network configuration here, we are going to add an Palo Alto firewall. Okay, and monitor the traffic. How it will be means, so whatever the switch will be available right in your network, that is okay sending your traffic code. Let's assume this is a WAN switch. Okay, this is a WAN switch where your traffic comes and receives. Okay, and your traffic goes out. So for that switch we are going to connect the firewall with an tap interface. Okay, here let's assume here ethernet 1/5 is the interface that we are configuring as an tap, and here in the switch that we are connected to the interface, right, that will be calling okay, connect okay configured as a span. Okay, so span in sense, we can calling also as a mirror. Okay, so here we'll be calling as an spanner mirror. Okay, mirror in sense how we stand in front of mirror. Okay, if you stand in front of mirror, the okay our reflection will be seen that side, right? In the same way we are going to connect one interface on the switch, and we are configuring that switch as an mirror. So this will be okay. Other side where the traffic is receiving, okay, other side where traffic is receiving, we can, this interface will be calling as an source mirror, and this traffic will be calling as a destination mirror. Okay, so while configuring that, okay, when we configure that, whatever the traffic receives on this interface will reflect on this interface as well. Means this is a source mirror and this is a destination mirror, right? Mirror in sense this is reflecting same whatever receiving on this interface. And once the traffic received on this interface, it is going to send to the firewall. Okay, obviously once the traffic receives on the firewall, we have discussed about monitoring and logging, right? So once the traffic receives on the firewall, it will be once the traffic receives on the firewall will going to log, okay, the traffic, and the traffic logs will be available. Okay, and whenever the administrator wants, he will log into the firewall, he will take the report. Okay, in the firewall we can also take the report. Okay, if you want 3 months or 6 months or 12 months or 1 day, 7 days or 30 days, likewise you can also take. Okay, you can take a report and you can verify what type of traffic that your network is receiving and what type of traffic that your network is sending out. Okay, that we can verify. The administrator feels, okay, if something is suspicious, he can identify the he can identify the suspicious activities and suspicious traffic that comes and goes to your network. Okay, so this trap interface will mainly use it for monitoring your network without changing any network configuration. Okay, we haven't changed anything here, we just added a span and created a span for that. That's it, we haven't changed anything IPs or we haven't changed anything in the network. Okay, that is a tap interface. Okay, and apart from tap interface we will be having layer 2, layer 3. Okay, so layer 2, when we configured specific interface layer 2, it will be working as a switch, and the okay, the forwarding the traffic will be based upon the MAC address. Okay, so it will also maintain MAC address table, and based upon the MAC address that it is receiving, so it is going to send the traffic out, or it is going to block. If the MAC address is not there, it is going to it will drop the packet. Okay, in the same way, if you configure one interface as an L3 interface. Okay, so we are going to mostly use L3 interface only. Okay, because our, okay, the devices that are connecting to our firewalls are L3 devices, or maybe our PCs. Okay, so mostly we are going to use L3 interface in our entire codes. Okay, so whenever you configure one specific interface as L3, it will be acting as a router. Okay, so how it will be means, so here in the firewall we will be having a network interfaces, and if you take this interface, inside the interface we will be having multiple types. Okay, so if you drop down, you will be having tap, HA, virtual wire, layer 2, layer 3. Okay, I have taken this as an layer 3. Okay, now this particular interface Ethernet 1/1 will be acting as a router, where we are going to configure one virtual router on this interface. Okay, so whenever you configure one particular interface as a L3, that will acting as a router, and it will be having an one virtual router where the routes are maintained. Okay, so if I want to show you, so here this will be Ethernet 1/1 is an default virtual router, right? So here we'll be having an one option of virtual router. This is a this is a router. Okay, and if you want to see the routes, you will be having more runtime stats. So route table, forwarding table. Okay, I think you know about route table and forwarding table, right? So this route table will contain all the routes that are, okay, that are configured or that are receiving from other neighbors. Okay, the forwarding table will be having, okay, most final destination addresses, or uh, the most shortest path. Okay, or the most we'll be calling as an the shortest path in the network that will be available in the forwarding table. Okay, so whenever you're configuring that, the routes will be taken care, and the traffic flow will be based upon this routing decisions. Okay, and in the virtual wire interface, next one is an virtual area interface. Okay, This is same like the tap interface. Okay, here in this tap interface we are just monitoring the traffic, and if administrator feels something is suspicious, they cannot do anything in the tap interface model. Okay, so if administrator feels some suspicious activities are happening in my network and he want to block that without changing any network configuration. Okay, he want to block without changing any network configuration. So what he is going to do is he is going to add a Palo Alto firewall in between the network. Okay, let's assume this is a network you will be having. Okay, these are the users that are available. This is your switch which is connected to the fire. Okay, let's assume there is no firewall now. Okay, the switch is directly connected to your firewall, and the firewall is connected to the internet. Okay, the administrator feels that he want to block something which is suspicious that is entering in the network. Okay, now he is going to install this. Okay, he is going to install the firewall, and the interface that is, okay, that is on the switch is connected to one interface of the firewall, and other interface of the firewall is connecting to the, okay, core firewall or any other core router that is available. Now what are the interfaces that are connected? The two interfaces that are connected on the firewall, right? These two interfaces will be in the vwire mode. Okay, means virtual wire mode. So here we'll be having that. Okay, so interfaces, take any interface type, and you will be having virtual wire. Okay, so if you select this interface will be in the virtual wire mode. Okay, we will be calling as an vwire mode, so that whenever the interfaces are in virtual wire mode, you don't need sorry guys, you don't need the IPs here. Okay, you don't need any IPs. The firewall will just acting as an transparent, and your firewall and also your switch will be not known that firewall is in between, but physically the firewall will be available, and it is monitoring your incoming and outgoing traffic. Okay, so now there is suspicious traffic receiving on your network. Okay, that is coming from the outside. Now the administrator, okay, identified that if you want to block, he can create the security rule. Okay, he can create the security rule. What are the suspicious? Okay, from where it is coming, what is the source IP that is coming? Okay, and from where okay, to where it is going, the destination IP, what is the port that is using, and what is the destination port it is using. If he is using any application to, okay, entering into the network, he also identify the application, and he is going to create a security rule. Okay, now he, whenever the traffic reaches on the firewall, it is going to block. Okay, it is going to block the traffic without, here we haven't changed any network configuration, we have just removed the interfaces and we have connected to the firewall. Apart from that, we are nothing changed in the in your network path. We have going to change only in the firewall, that we are creating an rules to block this unauthorized or suspicious traffic. Okay, that is about the virtual wire mode. So for monitoring purpose, just simply monitoring, you can configure tab, and if you want to monitor and if you want to block the traffic, we can use the virtual wire interface mode. Okay, and next one is an aggregate interface. So this aggregate interface will same work like your ether channel. Okay, so in Cisco, what you will calling ether channel or port channel? Sorry, both, right? So here in this case we are calling as an aggregate interface, where ether channel we are calling as an aggregate interface here. Okay, this aggregate interface you can see mostly on the hardware firewalls. Okay, but in the VM firewalls we cannot see. So this is a VM firewall which I have deployed in the okay, VMware. So in this case, so here in the interface tab you cannot see. Okay, you cannot see the aggregate interface. Okay, so but in the hardware firewalls you can see. Okay, if you take PA220, okay, you can log into the firewall, go on any of the interface. In that interface you can see the aggregate interface. Okay, you can create aggregate interface and you can add multiple interfaces to have redundancy and also scalability. Okay, to scale your bandwidth or to increase your bandwidth, so we are going with aggregate interface. Okay, And VLAN interface to specially carry our VLAN traffic. So we can create, okay, VLAN interface in the Palo Alto firewall. How we are creating okay, VLAN interface means, so we are taking one single port. In that single port we are creating a sub interface, okay. So how many VLANs that you have, that many sub interfaces you can create, okay. Assign one VLAN is to, okay, let's assume I have VLAN 10 and I have VLAN 20, and I'm assigning VLAN 10 to this sub interface, VLAN 20 to this sub interface. Whenever VLAN 10 traffic receives, this sub interface will be taken care, and whenever VLAN 20 traffic receives, this sub interface will be taken care. Okay, by using a single port, we can route multiple VLAN traffic as well. Okay, so if you want to create VLAN interface in the Palo Alto firewall, you can make use of the single port, which is the sub interfaces. Okay, and next one is a tunnel interface. So we have talked about VPN support, right? Like IPsec, remote access VPNs, or SSL VPNs, DM VPN, or GRE, okay, tunnels. In that case, we need to create a separate tunnel interface, okay. So this tunnel interface will be logical interface only, okay. Although we are configuring here, we will be having in the interfaces, we will be having tunnel interface as well. Although we are configuring a tunnel interface, so we are not directly connecting, okay, the physically not connecting, we are creating a logical tunnel interface between our, okay, firewalls to route the traffic in a secure manner. Okay, this tunnel interface will be used in such a way. Okay, these are the interface types that we have. Okay, any questions here regarding the interface types or hardware types? Yeah. Oh, okay. Mm, 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 mm. Yeah, that will define in the, okay, that will define in the firewall itself. Okay, you can have two interfaces, like one for primary and one another for secondary. We can create a, okay, routes here in the firewall to access. First, this is a primary, and if this primary goes down, the traffic has to be routed towards the secondary one. Okay, so in this case we have to, in the Palo Alto firewall will be having a metric. Okay, so in this metric, the the path which has lowest metric, that will be considered as a primary. Okay, so if for this you can configure metric as 5, and for this you can configure metric as 10. So all the traffic, application traffic, whatever receiving, it will be always flowing through this. Okay, once this is, okay, down, it will be removed from the routing table. Okay, it will remove from the routing table, and this path will be activated. Okay, and now the application traffic will be switched towards this path. We can configure in this way. So here in the virtual router, no. Actually, that is administrative distance, but metric will be having difference. In the static route, will be having different metrics. So if you see here, we'll be having administrative distance. This will be based upon the protocol. Got it, or do you have any questions? Hello. You are talking about this range, the destination range. This one. Uh, uh, yeah. Okay. Yeah, we can use range, or, okay, we can use range, or we can use directly subnet, or we can use single IPs as well. We can configure. uh, we can configure. We need to configure on both sides. Yeah. Any other questions? So for today, we'll be having an last topic called zones. Okay, as we have discussed this in the segmentation part. So in order to segment our network using an Palo Alto firewall, we need to create a zones. Okay, so in these zones we will be having, okay, let's assume you have this firewall. Okay, and you have one dedicated server or one okay, the server which is dedicated to your inside network. No one from the outside has to be accessed. Okay, in that case what we are going to do is we are going to create a zone, and what are the interfaces that you, okay, you need to access this server. Okay, let's assume this interface has the user, and one more interface has the user only. Here what we'll have, 1/3 1 slash, let's assume we have a 1/6. Okay, and here 1/7. Okay, so now for ethernet 1/1 we will be having an server connected. Okay, and now I want the user I want the user who are connected to ethernet 1/6 to access this server. Okay, what we are going to do is for this ethernet 1/6 we are going to assign the inside zone. Okay, like how we are checking here. So for particular interface, okay, so here we'll be having an option called zone. Okay, security zone. So whatever the zone that you want to assign it here. Okay, so I have one ethernet 1/1, I have inside zone. Okay, and in the same way for ethernet 1/6, so to access this server they have to include in this zone, right? So what we are going to do for ethernet 1/6, we are, okay, assigning this inside zone so that this user also will comes inside this zone. Okay, and he will be able to access. Now my, okay, another user which is connected to ethernet 1/7 will, okay, this user will not be or not supposed to access. So in that case what we are going to, we are not going to include this ethernet 1/7 user inside this zone. Okay, maybe he comes from outside, or he comes from another zone. Okay, so that's how we need to create a zones and assign the users or assign the interfaces who needs access to this particular traffic or particular access to the to inside of your network. Or if the users are lies outside, so we need to provide, we don't want to provide access to them, right? We can create separate zone and we can avoid accessing them from the zones. Okay, so here in this case we will be creating, okay, uh, three different types of zones. Okay, we can create multiple zones, but based upon our requirement in this course we are going to define three zones. One is an trust or inside zone, second one is an untrust or outside zone, and the third one is DMZ zone. Okay, what is trust zone or inside zone means, we are already discussed. Okay, trust zone which will be contains internal network that are considered secure and reliable, such as LAN network. Okay, we can call this as a LAN network as well. Okay, and this one will be calling as an WAN network as well. Okay, that I think in your terminology you can understand what are the LAN network will be there, that we can consider as an inside, because that inside LAN network will be safe and secure, and the traffic will be reliable. Okay, so that will be considered as an trust or inside. And the WAN network which is connected outside of your network might be to the internet or might be to any other, okay, public domains. So for that we are creating different zones, and we are adding that, okay, the interfaces to the these untrusted outside zones. Okay, and we'll be having an demilitarized zones. Okay, what is this demilitarized zone means? So let's suppose you have an firewall and you have created an, okay, this is your inside network. Okay, and you have created one more zone which is outside. Okay, And in the inside network you will be having your inside users. Okay. Along with the inside users, there are some servers which are publicly faced. Okay. So the servers which are publicly faced means these servers are available in the inside network but will be accessed using an public IPs. Okay, that will be calling as an publicly faced service. So if it has an public IPs, the whoever the users that are available in the public network or outside network, they are also going to access, right? Because these are public IPs, anyone can access if they have an IP. Okay, so in such cases, the outside users will be going to enter in your inside network. Okay, they may access not only public servers, they may access your internal use. Okay, internal network as well, or internal, they will get an internal access as well. Okay, so to avoid that situation, so what we are going to do, we need to, okay, separate these servers which are publicly faced. Okay, for that we are creating one more zone. Okay, we are creating one more zone called DMZ zone. Okay, so in this DMZ zone we are segregating and we are keeping the servers which are publicly faced. Okay, these are the these servers are available in your network only, but creating a different zone. Okay, with DMZ zone, demilitarized zone, so that whenever the users coming and accessing this network, they will directly going to this. Okay, they are not coming this side. Okay, they will directly going to this side, so that we can save secure our internal network. Okay, that is the main purpose of DMZ zone. Okay, and in the firewall, I told you, right, the users who are available in the same zone, they are going to access, and the users who are in different zone, they are not able to access anything. Okay, they are not going to communicate as well. Okay, so if you see here in the diagram, you can see the yellow arrows and red arrows. The yellow arrows who are available in the same zone, and the red arrow, they will be available in the different zone. Here one zone and also here one zone. They are going to block, the firewall will obviously going to block. Okay, so there, okay, we'll be having two types of zones. Okay, intra zone, which is within the zone. Intra zone means within the zone, we'll be calling as an inside zone. Okay, and inter zone, between different zones. Okay, the intra zone will be always allowed, and inter zone will always be, okay, denied by default. Okay, in the firewall, if you take any firewall, you will be having two default policies. Okay, I will show you that. If you take any policies, okay, if you take any firewalls, there are two policies will be available on every firewall. Okay, we are not going to create this, the firewall will itself will create. Okay, the firewall, okay, the default template will be there. Once you spin up the firewall, the default template will be added, and that template will be having these two policies. Okay, intrazone and interzone. Intrazone will be allowed by default. Okay, if you see here, the interzone is allowed, sorry, intrazone is allowed, interzone is denied. Okay, these are the two different zones and two different policies by default the firewall is having. Okay, how the access will be denied for the different users in different zone, and also the users in one zone is going to allow the access by the firewall. Okay, so this completes our okay, day one session, and day two will be having an packet flow. Okay, this packet flow will tells, once the firewall, once the traffic hit the firewall, how the firewall is going to, okay, validate the traffic, how the firewall is going to inspect, how the firewall is going to validate the traffic to send the traffic out. Okay, so that we can discuss in the tomorrow session. Okay, so do you have any questions regarding the today's class, whatever we have discussed till now? Yeah. Mm. You want to explain me again? Yeah, okay. See here, let me erase this first. సో బేసిక్గా ఇక్కడ డిఎంజీ జోన్ ఎందుకు యూజ్ చేస్తామంటే, సో మనకి ఇక్కడ ఏంటి అంటే, సో మనకి ఫైర్ వాల్ ఉంది. ఓకే, సో మనకి ఇదంతా ఇంటర్నల్ నెట్వర్క్. ఓకే, దిస్ ఈస్ అ అవుట్ సైడ్ నెట్వర్క్. ఇన్ ఇన్ అవర్ internal network there are multiple users who are internal to the internal network. Okay, so let's assume you will be having 10.10.10.0/24 network. Okay, this is our private network, and along with our private network there are servers. Okay, there are few servers which are publicly faced. Okay, let's assume you will be having a public IP 210.0.113.100, and this one also 203.0.113.200. Okay, we'll be having two servers. This is a inside only. Okay, but these servers will be having public IP. Okay, so if servers having a public IP instead of private IP, so anyone from the internet will able to access, because these are the public IPs, right? The firewall will be allowing the traffic from the public as well to allow the public. Okay, the traffic which is okay destined towards these firewalls. Okay, whenever the users that are available in the internet, they are trying to access the servers. Okay, so maybe they may be legitimate. Okay, who are going to access server, but some of them are will be intentionally going. Okay, they are acting like they are accessing the servers, but actually they are okay came to inspect our internal network. Okay, what's going on in this network, what type of traffic they are using, is there any is there something that they are going to use. Okay, that they are going to inspect. Okay, so to avoid that, so we need to separate these servers from our internal network to avoid the users which are available in the internet to directly come to our inside zone. Okay, for that reason we are going to create one more zone called DMZ zone, where this DMZ zone contains the servers which are publicly faced. Okay, this DMZ zone will contain the servers which are publicly faced. Okay, we are creating an DMZ zone for this purpose only. If you have any servers that are publicly faced, you better create a DMZ zone and assign these two servers in that DMZ zone. Okay, now the user who will be trying to access, okay, trying to pretend they are accessing the uh, public servers, they are not directly coming to your inside zone now, so they are going to DMZ zone. Okay, so now we are segregating the traffic from coming inside zone to DMZ zone. So they are directly coming to the DMZ zone, they can access, they can leave. Okay, they don't have visibility towards our inside zone. Okay, that is the main purpose of DMZ zone. Okay, got it? Or yeah, any other questions? Yeah. Mm, mm. Yes. VPN access అని చెప్పలేం కానీ VPN access will be different thing. Okay, VPN access mostly like protecting the okay our organization, and also whatever the traffic going from our inside zone inside network to the outside network. But in this case the traffic is coming from outside, right? That will be bit different when compared with VPN. Trusted and trusted. ఆ, ఇప్పుడు ల్యాన్ అంటున్నాం. ల్యాన్ అంటే మనకేంటి? మన ప్రైవేట్ ఇంటర్నల్ నెట్వర్క్ ఆర్ ప్రైవేట్ నెట్వర్క్. ఓకే, whenever you feel this is my private network, create your trust zone. Okay, for that particular network you can create trust zone. Okay, and whatever the traffic that you can consider as a WAN, which is okay, maybe you are mostly that WAN in the sense that mostly connecting towards the ISPs or connecting towards the internet, right? That we are whatever the interfaces or whatever the traffic that is going towards or from your from your router or firewall towards the internet or ISPs, that we can consider as an untrust, because we cannot trust who are available here what they are doing. But inside the network we can trust, okay, this is my friend only, this is my user who can do uh, reliable things, or who can do and okay activities that related to my okay work. So that we can call it as a trust. But outside the users we cannot trust them what they are doing, who are actually who are they. so that we can create the untrust zone or outside zone. Assign that. Yeah, that is a good question. Yeah, yeah, that is a good question. So I already told the users from one, okay, one zone to another zone, the firewall is blocking by default. But if you feel that we need to send the traffic from one zone to another zone, and we feel that that is a trusted, we can create security policy to allow traffic from one side to one zone to another zone. Okay, that is why we are creating here the policies on top of this. Okay, default policies. Okay, to allow the network from outside inside to outside, outside to inside, or from any zone to another. Okay, from any zone to different zone. If you want to allow the traffic, we need to create a security policy, like how you have allowing communication between users between two VLANs. How you can use a router, right? So in the same way, here we are going to use security policy to allow the users to communicate between two different zones. Yeah. Yeah. Any. Go ahead. No, here I said private, public IPs means public network, that will be, not the private. DMZ zone is where we are using in servers which are having public IPs, not private IPs. Okay. Just a minute. Sorry. Go ahead. You are saying something. Hmm. Hmm. Yeah, we can move if you feel that interface needs to be in inside zone. We can move. Go ahead. Okay. So not here. Network interfaces. So you feel this is interface which are okay, which is outside now. So if you feel this interface has to be in inside, go ahead and just simply inside. Click on OK. Okay, that will be coming to the inside zone. Yeah, that we can do, but that depends on our decision, whether it has to be inside or outside. Yeah. Yeah. Any other questions, guys? Yeah. Okay, so I will take it as no. So with this, we have completed our day one session. Okay, so I will going to provide, okay, this recording session once it is uploaded, maybe next half an hour or 1 hour. So go through this, okay, recorded session once again. If you feel you have any doubts, just store it for tomorrow session. We'll discuss in tomorrow session. Okay, tomorrow session is also very important, where we are going to discuss about the packet flow inside the firewall. Okay, I think as of now you have seen how packet flow on the link. Okay, in routing and switching, you're mostly seeing how the packet flow on the links, but tomorrow we are going to see how packet flow inside the device, means inside the firewall, how firewall is going to take the decision whether one traffic is entering, and how the traffic is leaving the firewall. Okay, if something is happen in between, the firewall will not send the traffic code. Okay, that's the decision will taken care by the firewall using this packet flow process. Okay, so please be, okay, join the tomorrow session. That will be very interesting as well. Okay, thanks guys, thanks for joining the today's session. Have a great day. Bye. Okay. Yeah, bye. Yeah, good night. Yeah.